Hey there, Quadratics Made Easy here, and today we'll be looking at a word problem based on height and flight. So this requires some concepts of quadratics. So the question is, the height of a rock thrown from a tower can be approximated by the formula h equals -10t squared plus 40t plus 120, where t is the time in seconds and h is the height in meters. So we're supposed to find out the height of the tower, maximum height of the rock, and the time when it reaches this height, at which it reaches this height, that is the maximum height, and when the rock will hit the ground. So I just drew a little diagram, which is what I call the path of the rock, and this is the little diagram which I drew. So let us say this is the ground over here, this part here is the ground, and this one over here is the tower. This is the little person that's throwing the rock, and this is the path of the entire rock. This is the path where it goes, this is when it lands. So this is when time, that is t, equals 0, and this is when height, that is h, equals 0. But that's because it's already touched the ground. We can kind of think of this like a parabola, where this is the y-intercept as t equals 0, and we're going to take this as the height axis and this as the time axis. So it's a height versus time parabola. And over here we can see that the height equals 0 at this point. This could be our x-intercept, and over here this part where time equals 0, that is when the rock is about to be thrown, that could be our y-intercept. And this part where h is maximum, that is our vertex of the parabola. So the path of the rock is basically a parabola on a time versus height graph. So let us look and find out our solutions. The solution to part A, that is the height of the tower. The height of the tower will be given when time equals 0. See, that is basically the y-intercept. So we're finding the y-intercept. How do we do that? We set x equals 0. That is, we set time equals 0. So h equals 10. Instead of t, we put 0, which gives us h equals 120 meters. Therefore, height of the tower equals 120 meters. Now let us look at part B. The maximum height and the maximum height and the time are at the time at the maximum height, that is the time that is elapsed when the rock is at maximum height at that particular instant, basically is the vertex of the parabola. As I said, from this diagram, little kind of path of the rock over here, at the h max, this is going to be the h max, and at a certain point of time it's going to be at that h max. So we're going to have to find that h max and also the time. So how do we find that? We can just find the vertex. So we find the vertex using completing the squares method over here, as you can see, and that leads us to h equals to -10 t minus 2 whole square plus 160. Therefore the vertex is 2, 160. So at 2 seconds time, the rock reaches a height of 160 meters, which is the maximum height. So the maximum height is 160 meters, and the time at maximum height is 2 seconds. The third part C, which is when the rock hits the ground, and that is basically asking us for our x-intercept. So rock will hit the ground when h equals 0. So we put h equals 0, and then we basically factor the entire equation, quadratic equation. We factor it, and we get t equals 6 or t equals -2. These are two possible solutions, but time cannot be negative. Time can only be positive. We never say -2 seconds, do we? We never say the time was -30 minutes. So time always has to be positive. The same thing is with length and area. So we neglect the negative value and we go on with the positive value. Thus the rock hits the ground at t equals 6 seconds. And that is a problem, and this is the path of the rock. And this is a problem on flight based on quadratics. Thank you.